Shall we start now?
Yes, sir.
Yeah.
Yeah. Hello, everyone. So today we are going to see some sums in functions. Shall we start the class? Of course, we can start the class. So we are gonna see some 3 7-mark sums today and some 2 marks. Okay. Shall we start? Okay, start. So I will first write the questions and we discuss the answers. So the question is, let F maps A to B, IA and IB be identity functions on A and B respectively. On A and B respectively. Then prove that F circle IA equals F equals IB circle F. Okay. Here, what they given is F max A to B is a function and IA and IB are the respective identity functions of A and B. IA is the identity function of A, IB is the identity function of B. So what we are going to prove here, F circle IA equals F equals IB circle F. Okay, whatever the sum may be, we are first going to write the given. Then we are going to write whether we going to find something or we are going to solve something or we are going to prove something. Here what we are going to do, we are going to prove. So first we are going to write given. So what is given? F maps A to B is a function. Right? Then what they are given? IA is the identity function on A. IB is the identity function on B. Right? This is what they have given to us. What they ask us to prove? We are going to prove here. So to prove F circle IA equals F equals IB circle F. This is what we are going to prove here. Right? So what we are going to prove? We are going to prove a function equals another function equals another function, right? To prove here, we can split it up into simple sums. First, we can prove this, and second, we can prove this, and finally, we can merge it up, right? For proving two functions are equal, we have to do two things. First thing, we have to prove the domain is same. Domain of two functions are same. So if we are going to prove this is equal to this function, then both the domains should be same. Then the second thing is we have to put a random element in both the functions and we have to check the way they react. The output form will be equal so that we can conclude that both the functions are equal, right? So I will give you 1 minute of time so that you can copy down this, right? Okay, guys. I hope you copied down. Shall I move to next? Okay. So if you are if you can do listen and copy at both time, it will be okay. But be clear you are listening properly, right? Right. So now we are going to solve this one, right? We are going to prove it. So first proof. First thing we are going to do for to prove. What we are going to prove here? You can write it like this. Proof of proof for what? So we are going to split it up, right? So first we are going to make a proof for F circle IA equals F, right? Okay. So for that first we are going to make sure the domains are same. Fine. What they given? IA, FA. Okay. They have given function F and IA. IA is a identity function. So IA maps A to A. What is mean by identity function? Identity function is a function in which if whatever the input may be given, that will be the output for a same set. The thing is the input and the output will belong to the same set and it will be a unique like constant. If we give some A in A as input to the function, the output will be also A. They both belongs to A, right? Fine. IA is a function. IA maps A to A, right? Because it is an identity function. Is a function, right? And F they already given. F maps A to B is a function, right? Why should I write IA first? While solving these kind of sums, we have to take this from right hand side. So that I take IA first, right? And I put F first, right? Then what will be F circle IA? See, here A is a domain, A is a codomain, A is a domain, B is a codomain. IA's codomain and F domain are same. So the final domains and codomain will be domain of IA maps to codomain of F. Likewise, you simply cancel it out and directly take this. When these both are same, right? Is also a function. That's it. Already we know F maps A to B is a function. Who is the domain of F? A. Who is the domain of I circle IA? A. So, F circle IA and F are defined on the same domain A. Okay, clear? So, we proved that both F circle IA and F are in the same domain, right? Clear? Clear. Now we are going to do for the element part. For that, I will consider element A. Let element A belongs to the set A. The small letter A will be considered as an element in a set A, right? So I am going to keep this element in both the functions. Okay. So I am going to take this left hand side to prove that it is equal to F. So F circle IA of A equals. So we can write F circle IA as f of IA of A. Right? Right. As I said already, IA of A equals to A. Why? Because IA is an identity matrix. Sorry, IA is an identity function where when you give an element from A, so element from set A as an input, the output will remain same. So IA of A is equal to A for all A belongs to A. Right? Right. So we can substitute A instead of the entire term, which is equal to F of IA of A will be A. Right? Right. Now you can see we are giving an element from A as input. The output will also be a function of A. So when you give something as an input, the same will reflect as output, then will be a identity matrix. Right? That's what we substitute IA of A will equal to A. So we put A. Right? Right. So we have to prove, if we have to prove two functions are equal, we have to do two things. So first thing is same domain and elemental reactal way. So first thing is same domain. We did it? Right, we did it. Second thing is we have to put some element in it and we have to test the function. Yes, we did it. So from both these things we can say F circle IA equals F. Right? Is it clear? So I will mark it as equation 1. Right? Now I will give you 2 minutes so that you can copy this down. Okay, guys, I hope you copied this. Shall I rub it? Yes, of course. Okay. So what we did? We did the proof for first half. Now we are going to take the second half. Proof. So what we are going to prove? IB circle F equals F. Right. Shall we start again? Right. Now we are going to find the domains of both the things and we are going to put the elemental trial and we are going to find whether they are equal or not. So here we are going to prove, right? First. We are gonna, which one we are gonna explain the domains, either IB or F. Yes, of course. We have to start with F because we have to start with the function which is on our right hand side. So who is here? F is here. F maps A to B is a function. Right? Right. IB. IB is a identity function, right? So it will be mapped from B to B. It's a function. So IB circle F. What will be its domain and codomain? We already see this, right? So we have to check both of this. If they both are equal, we can directly take this. So here, both codomain and domain of these functions are equal. So we can directly take A to B. okay, is also a function. Fine? Fine. So now shall we compare both these functions domain and this functions domain? Okay. If you consider the entire thing, domain will be A. Okay. If we take the right hand side, here is a function f alone. Who is his domain? A. So domain of IB circle F and domain of F for A. So the both domains are same. Shall we write it down? Yes. IB circle F and F are defined on the same domain. Which domain? A. Right? So we solved the first step. We are gonna find whether both the functions are lie on a same domain. We did it. They both lie on a domain A. Super. What we are gonna do next? Yes, of course. We are gonna do next is we are gonna put on random element into this function and we have to check whether how in which way it behaves. So let's take element A belongs to set A. So small letter A represents element, capital letter A represents a set. Okay. So we are going to substitute this in left hand side and find the right hand side, right? IB circle F A. Now we are going to expand IB circle A. So IB of F of A. Right? Right. So now we are going to find whether this f of a belongs to a or b. Yes. From a function itself, we can know that f function maps a to b. So function of a will already belongs to b. Shall we write it down? Yes. F maps a to b. So we have f of a belongs to b. Okay, there will be little bit confusion, right? A belongs to set A, but f of A belongs to B. Okay. So I will clear this out. When you consider A, it is a basic input element, but f of A is like a final output. So here we can see, what will be the input? A will be the input. What will be the output? B will be the output. So function of A will be equals B. Fine? Fine. Okay. So it belongs to B. Fine. Here what we have? It's an identity function of B. So when we put an element from B in identity function, what will be the output? The same will be the output. So shall we check it? Yes. We have an element from B. We are putting the element from B into the identity function of B. So the output will be f of A. Right? Right. So IB circle f of A equals f of A. Okay. To prove both functions are equal, we have to do two things. First is both their dimension should be same, and we have to check by putting a random element and verify the outputs. We done both of this, right? We check both the things are lie on a same domain, and we put a random element from set A and find the output, right? Okay. So from both of this, we can conclude IB circle F equals F. Already we have an equation 1. So I will name it as equation 2. Right? I will give you 2 minutes so that you can copy down. We will move to the next step. So we already proved that two parts of the equation. First part we already proved. Second part we proved here. So we are going to just combine both of them and make it as a final proof. Right? Did you copy? Okay, the board is clear. Okay. Shall I clean the board? Okay. What we have as equation 1, F circle IA equals F. We have it as 1. What we have it as 2? Sorry. IB circle F equals F as 2. So now we are going to combine both of this from 1 and 2. We are going to combine F circle IA equals F. Right, first one. Where F is again equal to IB circle F. So this is what we have to prove. Right? Did we prove it? Yes, we proved it. Hence proved. Right? Are you clear? Do you have any questions or doubts in this sum? Okay. Okay. Did you guys copy it? Shall I wrap and move to next sum? Okay. 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 Let's start the second sum. Let F maps A to B be a bijection. Bijection. Then prove that F circle F inverse equal to IB and F inverse circle F equals IA. Right? Right. What they given? They given F maps A to B is a bijunction, right? Bijection. And then we have to prove two things, right? Shall we start? Yes, of course. So, is the board is clear? Okay, thank you. So, we are going to start the another problem. Whenever we start, we are going to write what? Super. We are going to write given first. What they given? They given is F maps A to B is a bijection function. Bijection function. Right? Right. What they ask us to prove? They ask us to prove two different things. First is F circle F inverse equal to IB. And the second is F inverse circle F equals I A. Right. So here they given a different word called bijection. What is mean by a bijection? Right. So normally if a function is written as a function map, F maps A to B means if you put A as input, right? I given A as input means the output will be from a set B, right? It is a one way like method. But what is a bijection means? It will act it in a two-way, right? If we inverse the function, right? For example, the function is like multiplication means if we inverse it into the division, the output will goes return. Like, uh, okay, so we can draw like this. It's a function, right? If we give A as an input, the output will be B. If we inverse it and give B as an output, if the system produces the initial input A, then it will be considered as bijunction, right? So initially A is given as input to the function, it will produce B. If the function is inverse, we give B, it will produce A, right? Right. It is a bijection function, right? Right. Shall we start to solve? Yes, of course. So first one, the first proof, we are going to take it for first thing. First we are going to prove first thing. F circle F inverse equals IB. Right? Right. Okay. Here we are going to do, sorry, we are going to make two functions are equal. We are going to prove that. To prove two functions are equal, what we are going to check? We are going to do domain first and element, random element test again. Okay? Right. So do you guys copied it? I will give you 2 minutes so that you can copy and we can start this proof right from here freshly. Okay. I will rub it down. Super. So proof for what? First one. F circle F inverse equal to IB. Right? Shall we start the proof? Proof. First, F maps A to B is a function. It's a bijection function. Right? If we see, then if you we already see it, right? If F inverse means the function will be reverse maps. So F inverse maps B to A is a bijection function. Clear? Clear. So what we are going to find? We are going to find a domain for F circle F inverse. Shall we find it out separately? Okay. So who is on our right hand side? F inverse. So F inverse means maps B to A. What about F? Maps A to B. Right? Here both of them are same. So F circle F inverse domain and codomain will be B to B. Right? This is what clear? The same thing we did it in the previous sum also, right? If anybody have doubt on this, no means we can proceed. Okay. So now we separately find the domain and codomain for this function. So F circle F inverse maps B to B, right? Is also a bijunction function. Is also a bijection function. Right? Right. What about IB? So IB is an identity matrix. So here domain and codomain both will be B. So B maps to B as a bijection function. Right? Right. What we are going to check? We are going to check the domains of both will be same or not. So who is the domain of F circle F inverse? B. Who is the domain of IB? B. So we know that both are same. So we can write it like this. F circle F inverse and IB are defined on the same domain. Who is the domain? B. Right? Clear. So we proved that both them are in a same domain. Kindly copy this guys because I'm gonna rub this and make it the next step. Okay. I hope you copied this. Shall I rub? Okay. Okay, super. First step is we have to prove both the domains are same. We did it. So what will be the second step? Yes, of course, we gonna test it with the random element. Before that, we take let element B belongs to B. Why should I take a element B? Because we are gonna prove this function is equal to the identity function of B. So I take a element B from the set B, right? Right. Since F maps A to B is a bijection function, right? So A to B is a bijunction function, right? So if B belongs to B is an element in B means there will be a same element will also exist in A. Same element, no? Same kind of element. So there exists A belongs to A, right? Since the function f is a bijunction function, if B belongs to B is an element, there must be a similar element in A. So A belongs to A, right? Such that we can take f of A will be equals to B, right? Right. Whenever we put this A element in A in the function, it will produce the B element in this set B, right? Right. Why? It is a bijunction function, right? Okay. Now I am going to inverse this function. So F inverse of B equals A, right? Right. Okay. So we have to rewrite this as F inverse of B equals A. Right? Right. Now we are going to put this element in this function. So F circle F inverse of B equals. Now we are going to expand this F circle F inverse. So F of F inverse of B. So what we have here? F inverse of B. What is F inverse of B? From the above equation we know F inverse of B is equals A. Okay. Again F of A. Where we see F of A? Here. So F of A equals to B. So we can substitute B instead of F of A. Right? Right. So a little bit clear. Watch closely. We put an element B. Right? So what will be the output? The same element. Whom it resembles to? Yes, of course. It resembles to identity function. Identity function is a function in which only in that function whatever the input is given the output is same. Right? What I given as input? Element B. What I got as output? The same element B. So here we can think who will I replace here? So we already know that IB is equals to B. Right? So I can replace it here, right? So F circle F inverse is equal to IB. Right? Right. I proved it. Sorry, we proved it, right? So I will explain this one once again because it seems to be little clumsy, but it is a easiest one, right? What we take? We take an element B from set B. Why we take B? Because we are going to prove this one as an identity function of B. So I take this. Since the given function is a bijection function, if an element B belongs to B, there must be an element A belongs to A. Okay? Such that if you put A in this function, it will produce the output B. Right? So f of A equals B. Then I will do what I will do? I will inverse the function. Okay? If we inverse a function, if the function is a bijection function, the initial output will, the final output will be the initial input. So I inverse it. Like you can simply remember I take this F here. So I inversed it. So A equals F inverse of B and I rewrite it in this form. Right? And I substitute the element B in this thing. F circle F inverse of B. So I expand it F of F inverse of B. What we have F inverse of B equal to A. I substituted it. And F of A equals B. We put it. Right? If input is given and the output will be the same, which both belong to the same set, then it is a identity function. So here we can take IB is equal to B. So that F circle F inverse equal to IB. Clear? Clear. I will give you one more minute to copy this down. Do you have any doubts? If you have any doubts, you can feel free to ask me. Okay, I hope you guys take this down. Shall I rub it? Okay. So we are done with the first part. Now we are going to move towards the second part. What is the second thing I have to prove? Second thing I have to prove is F inverse of F equals IA. Okay, shall we start the proof? Okay, what we have here? F. So F maps A to B is a function, right? It's a bijection function. Bijection function, right? Okay. First thing what we are going to do now? Yes, of course, we are going to do now is to prove that both the functions lie in a same domain. We are going to prove this function and this function are in a same domain. Okay. First function, first we are going to write it out the left hand side. Who is here? We're gonna start from this guy, the most last person in the right. So who is he? F. F maps A to B is a bijunction function. Then who remains? F inverse. F inverse means B to A as a bijection function. So whom we are going to get a demand? F inverse of F inverse circle F. Okay. So shall we check it out? F maps A to B. F inverse maps B to A. So while writing this, be clear. We are taken this. We are going to writing the domain for F inverse circle F. So whom you start to write first? Down who is in a right hand side. So we have to start from this guy. So F maps A to B. Then who is at the second? F inverse maps B to A. So what will be the final? F inverse circle F equals. So both are same. We gonna write this both. So A maps to A. Okay? Clear? Clear. So F inverse circle F maps A to A. Is it clear? Okay. It's a bijection function. Bijection function. Right? Right. What we have in another side of this equation? IA. IA is an identity function. So what we are going to give us mappings? A to A. So identity function, the same will be the domain and codomain, right? So for IA, A to A is a bijection function, right? Okay. Now we are going to check if both the domains are same. Okay. F inverse circle F. Who is the domain? A. I of A. Who is the domain? A. So what we can conclude? Both are defined on the same domain. Shall I write it down? Yes. F inverse circle F and IA are defined on the same domain. What is the domain? A. That's it? Yes, of course. So next what we are going to do is we are gonna put a random element and find both the sides of the function are behaving in the same way. Okay. I will give you another 1 more minute to copy this down. Kindly copy this first. Okay, shall I rub it? Okay. Super. I'll write it. Super. So what is the next part? We are going to check with the random element, right? Right. So here also I'm gonna take let B belongs to B. Since we already know this, F A map F maps A to B is a bijection function. If if a function is a bijection function, if B belongs to A means there must be an element exists, which is A belongs to A until one condition f of A is equal to B. Shall we write it down? Okay. There exists A belongs to A such that f of A is equals to B. Okay. If we inverse the function, A equals F inverse of B. We can also write this as F inverse of B equals A. Right. Keep this 2 in mind. Now we are going to substitute a random element in this function. F inverse of F. So what we are going to prove here? It's an identity function of A. So I'm going to substitute the element A. We can expand F circle of F inverse circle F as F inverse of F of A. Right? Right. Who is F of A? F of A is, we know that right here. F of A equals B. Right? Okay. Then who is F inverse of B? Which is A. Right? Right. Okay. Now listen clearly. What I given as input? A. A belongs to whom? Set A. Right? What is the final output? The same A belongs to A. So we can also say that I of A belongs to A. Right? So we can write F inverse of F inverse circle F equals I A. Right? Right. We already proved the first thing. Now we again proved the second thing. Right? For proving this, in the previous step we proved both have a domain A. Now we tested it with a random element from set A and we proved it. When we give us input to this function, the output will be same. So hence it is a identity function. So we proved it, right? Finally we can write hence proved. Okay, I will give you another 1 more minute to copy this, right? And we will move to the next sum. Okay, guys. I hope you copied this. Shall I rub it? Okay, super. Okay, do you guys have any doubts? No, right? Okay. So shall we start the next sum? Yes, of course. The next sum is let F maps A to B and G maps B to C and H maps C to D. Then prove that H circle G circle F equals H circle G circle F. That is composition of functions. Of functions as associative. Okay, what they given? They given three different functions, right? It's D, right? And they were ask us to prove F circle G of G circle F. And again, first they did H circle G, then with circle of F. They ask us to prove this composition of function is associative, right? Shall we start? Yes, of course. Whenever we start, we will start from given, right? What they given? They given about three functions. F map A to B is a function. Superb. Then G maps B to C is subfunction. And again, H maps C to D is subfunction. Right? What they ask us to prove? To prove H circle of G circle F, right? H circle G of circle F. We are going to prove this, right? Okay, fine. So kindly copy this. Okay. Now we are going to make prove that both these functions are equal. To prove this, what we have to do? We have to first prove both lie on a same domain, right? Second is what? We have to test this with a random element, right? I will give you 1 more minute to copy this. Kindly copy it fast. Time is running out. Okay. So shall we start the proof? Shall we start the proof? Proof. Okay. First we are going to consider the left hand side, right? Okay. What is left hand side? H circle, G circle, F. Okay. Uh, in maths, if something is within bracket, we have to do it first. So who is within bracket here? This guy, right? So if you are going to see about domains, whom will we will write in the first element to start up? Yes. Who is at the right hand side? So now we are going to take the domain for G circle F. Who is at this right hand side? F. So F is a function. F maps A to B as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Right. Who is remaining? G. Okay, G maps B to C as F function, right? Now we are going to write the function for entire G circle F. G circle F. Shall we write the domain? Okay, F maps A to B, G maps B to C. Here both these guys are equal and same. So F circle G lies on domain A to codomain C, right? Is it clear? Right. So F of G maps, sorry. G circle F, sorry I written it wrongly. G circle F lies in which? A maps to C, right? Okay. Because F maps A to B, G maps B to C. These two guys are same, so we can take this directly. So A maps to C, right? G circle F lies on domain A, codomain C. So G circle F maps A to C as a function. Right? I will wrap this. Okay. Now we already find the domain for this guy. Now we have to do for whom? This one. So H already given. H maps C to D as a function. Right? Right. So H circle G circle F. Okay. So whom gonna write it first? G circle F. Who maps to A to C, right? Right. Then whom comes next? H. He maps to C to D. These guys are same. So H circle, G circle, F maps. Directly we can write A to D. Right? H circle, G circle, F lies on domain A to codomain D is also a function. Okay? Okay, super. We found a domain for this guy. H circle, G circle, F. We have to find the domain for whom? One who is at our right hand side of the equation. H circle G of F, right? Right. As I said earlier, one who is inside the bracket will be considered first. So we are going to find a domain and codomain for H circle G. Shall we find H? Shall I? No. According to this rule. Which rule? First we have to write it for F. So while finding domain, we have to start it from a rightmost guy. Who is at right? F. F maps A to B is a function. Right. Done. Now we are going to find it for H circle G. Shall we start? Okay. So G. G is a function maps B to C. Who is remaining? H. H is a function maps from C to D, right? Here both these guys are same. So H circle G maps from B to D, right? B to D as a function. Now we are going to find it for the entire thing, right? So who is on the right side? F. F maps from A to B. Who is on the next? H circle G. They lies between B to D. This both guys are same. So we can write H circle G circle F maps A to D, right? Right. So shall I write it here? H circle, it's H circle G circle F lies maps A to D, right? I will rub it out. S also a function, right? Shall we check both the sides? Okay. He's at the left hand side, he's at the right hand side. Now check both their domains. Both their domains are A. So what we can conclude, both their domains are same. Shall we write it down? H circle G O circle F and H circle G circle F are defined on the same domain A. Okay, clear? To prove two functions are same, we have to first find their domains and we have to prove that they both lie on a same domain. Did we do that? Yes, we do that. We prove that both the sides functions are lie on a domain A. I will give you another 1 minute. Kindly copy it down. Okay, now we are done with the domain part. And what we are going to do again? We are again going to do with the random element, right? Okay. Shall you guys copy it? Okay. I will rub it and we will continue the second part. Okay. For that, let me take let A belongs to A, right? So I'm going to substitute in a left hand side. So H circle, G circle, F, right? We're gonna substitute the element A. So, and I'm going to expand that. H of G of F of A, right? Now we are going to see it differently. So initially we are going to say, consider the entire F of A as an element. So what we can rewrite it as H of G. That means H circle G. We can consider it as a thing and we are going to treat F of A as an element, right? Right. Now they both lie in a state of offset. We are going to replace it as H circle G circle F of the entire element A. Right? Right. We already proved that both their domains are same. Now we also proved that when we put a random element, the output will be reacted in a same way. So we can write H circle G circle F, H circle G of circle F are equals. Hence proved, right? That's it. Remember that in the sum, these brackets are so important. We proved the entire sum to make sure this bracket mode here remains the output is same. For that we do this entire thing. So be careful with the brackets, right? Right. So I will give you another 1 more minute to copy this down. I hope you guys copied this down. And it's time. So I hope you all understand these three SAMs very well. And it's our time. We have to end our session. And we will meet it in another session. Okay, guys? Thank you. Do you have any questions? Like, did anybody have any queries or any doubts you can ask? Or else you can copy and leave. Thank you.
Now, class over.
180 डिग्री 90 डिग्री या फिर 95 डिग्री यस इट इज 90 डिग्री क्योंकि वहां पे राइट एंगल फॉर्मेशन होता है लाइंस के
मैम
बीच
क्लास
में,
ओवर
इसलिए राइट एंगल कितना मेजर करता है
Okay, sir. Shall I leave now?
Yeah, yes, ma'am.
Okay, sir. Whether I have to wait till you end the meeting or I can leave?
No, ma'am. Now will I end the meeting.
Okay.
Yeah. Thank